Welcome to Revitalize Education. Today we're going to be discussing medication calculation using dimensional analysis. Dimensional analysis is a method used to multiply the given data and its units by the appropriate unit factors so that only the desired units are present at the end. In this example, we're going to try and figure out how many seconds are in one day. So in order to solve for that, the first thing I'm going to do is say that there are 24 hours in one day. And the reason I'm putting day at the bottom here is because if you go down and look at our desired units, day is on the bottom. So we're going to put day below the divide line here. And now we need to figure out how to get down to seconds. Well, we can convert hours into minutes. So there are 60 minutes in 1 hour. And then there are going to be 60 seconds in 1 minute. So once we get to this point, we can cancel out the units that are on the opposite side of the divide line. So in this case, minutes is present here as well as present here, hours is present here as well as present here. So we're left with days on the bottom and seconds on top, which is exactly what we want down here. So at that point, what we do is we multiply everything on the top and everything on the bottom. When we do that, we find out that we have 86,400 seconds, and we keep seconds because that is the remaining factor or the remaining unit on top, divided by what's multiplied on the bottom here, so 1 times 1 times 1, which is 1, and the carried unit is day because that's the last remaining unit that hasn't been canceled out already. So your answer for how many seconds per day are there is 86,400 seconds in one day. So let's use some medical examples here. The first example we're going to use is Levophed. You've got a concentration of Levophed that is 16 milligrams in a 250 ml bag. The patient weight is 55 kilos, and the dose is 0.7 mics per kg per minute. So in order to do this, the first thing that I do is I set up my weight and my dose right off the bat. So what we're going to do is we're going to put the weight, so 55 kilos, and then we're going to times it by the dose. Now the dose is written 0.7 mics per kg per minute, but for the sake of this, what we're going to do is we're going to put 0.7 mics on top, and then what we're going to do is put kilos and minutes on the bottom. And the reason that we do this is actually you can rewrite 0.7 mics per minute as 0.7 mics per kg per minute. Because what we're doing is mics is divided by kilos and mics is also divided by minutes. So we're just rearranging it here on the opposite side of the division line. Now we're not quite down to our desired units, which is mLs per hour. So what we want to do is we want to take this a step further and incorporate our concentration. Now our concentration is in milligrams, but we're given micrograms in our dose. So we have to convert micrograms to milligrams. So in order to do that, what we want to do is say that we have 1,000 mics in 1 milligram. And now that we have milligrams on top, what we can do is we can incorporate our concentration. So you have 16 milligrams on the bottom, and we put it on the bottom so that we can cancel out our milligrams and our milligrams, and we're in a 250 ml bag. So at this point, like I started to do, we cancel out our units. So milligrams and milligrams cancel out, micrograms and micrograms cancel out, kilos and kilos cancel out, and we're left with minutes on the bottom and mLs on top. Now we're close to milliliters an hour, but we still are left with this minute, and we need to convert that to hours. So what we need to do is say that there are 60 minutes in 1 hour. Now at that point, you can cancel out minutes, and you're left with mLs on top, and you're left with hours on the bottom. Now that you've got the desired units, what you want to do is multiply everything on the top and then everything on the bottom. So when we multiply that out, what we end up getting is 577,500 mLs And then on the bottom, it's 16,000 hours. Now that's a pretty ugly number, and we can simplify that even further. Now when we divide 577,500 mLs divided by 16,000 hours, what we end up with is 36.09 mLs per hour. So that's what your pump should be running at. Now let's try another example. So in this example, we have Levofed with a different concentration. This time we're using 5 milligrams in a 250 ml bag. Our weight's going to remain the same at 55 kilos, and the dose is going to remain the same at 0.7 mics per kg per minute. So just like we did before, what we want to start out is using our weight. So in this instance, we're going to use our weight of 55 kilos. And then we're going to incorporate our dose. So 0.7 mics per kg per minute. Now that we have mics, we need to convert that to milligrams so that we can incorporate our concentration. So once we do that, we say that there are 1,000 mics in 1 milligram. Now that we have milligrams, we can incorporate our concentration. So you have 5 milligrams on the bottom and 250 mLs on top. Now that we've done that, we can see whether we have the desired units because we now have milliliters on top, but do we have hours on the bottom? We're still left with minutes on the bottom, so we need to cancel that out and take it one step further. So we have 60 minutes on the top and 1 hour at the bottom. Now that we can cancel out our units and double check that we have the desired milliliters per hour as our remaining units. So you have minutes here and minutes here, kilos here, mics here, milligrams and milligrams, and you're left with milliliters on top and hour on the bottom. So now that you have your desired units, you can multiply everything on the top and multiply everything on the bottom. At this point, when you multiply everything out, you get 577,500 mLs on the top, and that's divided by 5,000 hours on the bottom. Now that's pretty sloppy, and we can convert that farther. If you divide that down, you end up getting 115.5 mLs per hour. So that's what your pump should be running at. Now, we have the exact same dose and weight as before, but our concentration was different. So this is a great example. If you have a patient who is fluid overloaded or you need to restrict fluid for whatever reason, this is a great example to show that you can slow down this rate and ultimately the amount of fluid that you're giving this patient by asking the pharmacist to make the Levofed drip more concentrated. Rather than making 5 milligrams in a 250 bag, perhaps they could do 8 or 16 milligrams in 250 to make it more concentrated and run at a slower rate. Now, the next example we're going to use Levofed again. We're going to use that 16 milligrams and 250 concentration, and our patient weight now is going to be 75 kilos, and we've got a new dose at 0.5 mics per kg per minute. So just like before, we're going to start off with the weight, which is 75 kilograms, and then we're going to incorporate the dose. So 0.5 mics per kg per minute. Now that we've done that, our concentration is in milligrams, so we have to convert that. So you have 1,000 mics in 1 milligram. And now that we've got milligrams incorporated in there, we can incorporate the concentration. So you have 16 milligrams in a 250 ml bag. And again, we're not done yet. We still need to convert your minutes to hours. So you have 60 minutes in 1 hour. So now you can double check, make sure that you can cancel out all of your units. And now that you know that you are left with only mLs per hour, you multiply everything on the top and then everything on the bottom. And when you do that, you get 562,500 mLs per 16,000 hours. Now that's pretty sloppy and we need to convert that a little bit further. So when you divide that out, you end up getting 35.16 mLs per hour, which is what your pump should be running at. Now, if for whatever reason your pump isn't running at that, but you confirm that you should be running at 0.5 mics per kg per minute, and you've confirmed the concentration is correct, this is one that you really want to make sure that the dosing weight that's in the pump is the same that you're using for your dosing weight. Occasionally, we'll find that those are different, and that kind of creates some errors when doing med math with that. So this next medication that we're going to talk about is Precedex or dexmedetomidine. In this instance, we're going to say that you have 400 mics in a 100 ml bag, and your patient weighs 25 kilograms. Now your dose is 0.2 mics per kg per hour. Now, what we've been using is mics per kg per minute, and normally when you talk about pressors or vasoactive medication, they tend to run in mics per kg per minute. But when you switch over into sedation, you tend to be mics per kg per hour. So just like we did before, when we're trying to figure out how many mLs per hour that is, we're going to start with the weight. So we're going to do 25 kilograms, and now we're going to incorporate the dose, which is 0.2 mics per kg per hour. Now again, we've been dealing with minutes, so make sure that you're incorporating the right unit here. So in this case, hours. And we've been using milligrams as our concentration. However, we've got micrograms in our concentration and we've got micrograms in our dose. So we don't need to convert from micrograms to milligrams, and we can just incorporate those micrograms or that concentration right off the bat. So we have 400 mics in a 100 ml bag. And now we've got mLs on top and hours on the bottom, and we can confirm we've canceled out all the remaining units and we're left just with mLs per hour. So now that we've done that, we want to make sure that we multiply everything on the top and multiply everything on the bottom. And when you multiply that out, what you end up getting is 500 milliliters in 400 hours. So again, hours are carried over and milliliters are carried over when you multiply everything out. And if you simplify that down, you end up getting 1.25 mLs per hour. And that's what your pump should be running at. Let's try another example of Precedex. In this instance, we're going to use Precedex 200 mics in a 50 ml bag. The new weight is 33 kilos and your new dose is 0.7 mics per kg per hour. So again, just like before, what we're going to do is start off with the weight. So in this instance, we're going to do 33 kilograms and we're going to multiply that by the dose. So 0.7 mics per kg per hour. Again, it's really important that you make sure that you're not putting minute down here or you'll really mess up your rate. So 0.7 mics per kg per hour. And again, we already have mics in our dose as well as our concentration. So we can just carry that over. So 200 mics in 50 ml bag. And now we've got mLs on top and kilos on the bottom. We want to ensure that we've canceled out all the other units and we're left with just mLs per hour. And at that point, you multiply everything on the top and everything on the bottom, and you end up getting 1,155 mLs and 200 hours. So once you simplify that down a little bit further, you end up getting 5.78 mLs per hour. And that's what your pump should be running at. Now let's do another one. This one, we've got ketamine, 200 milligrams in a 100 ml bag. The patient weighs 63 kilos and your dose is 0.5 milligrams per kilo per hour. So now we're changing our dose from mics to milligrams, and again from minutes to hours because generally we're dealing with sedation. So for ketamine, again, we're going to start out with our weight. So 63 kilos. We're going to times that by our dose, 0.5 milligrams per kilo per hour. Now we've got milligrams here and milligrams in our concentration, so we don't need to convert to micrograms. you're going to do 200 milligrams in a 100 ml bag. Once you do that, you have hours on the bottom, milliliters on top. You want to make sure that you can cancel out your remaining units, and you're left with just mLs per hour. At that point, you can multiply everything on the top and everything on the bottom. And when you do that, that gives you 3,150 mLs per 200 hours. So once you cancel that down even further or simplify it further, you end up getting 15.75 milliliters per hour. And that's what your pump should be running at. So our next example is labetalol, 200 milligrams and 200 mLs with a patient weight of 75 kilos and a dose of 0.5 milligrams per hour. Now, a lot of people would stop right here and say, well, this is really easy mental math. You have 200 milligrams and 200 mLs, which is the same as 1 milligram per ml. And if I'm running at 0.5 milligrams an hour at 1 milligram per ml, I'm going to run at 0.5 mLs per hour. Now, while that's not a bad thing to do necessarily, anytime you incorporate mental math, there's a chance that you can make a mistake and ultimately end up creating a med error. So I don't recommend doing mental math simply from the fact that it creates an opportunity to make a mistake. If you're going to be using this as a double check, I really recommend drawing it out longhand to ensure that you're not making a mistake or a med error. So with that being said, we're going to start from the very beginning like we normally do. Now, normally we'd be using our weight to start, but if you notice, you have a non-weight-based dose, 0.5 milligrams an hour. So because it's not weight-based, rather than starting with the weight, we're going to just start with the dose, which is 0.5 milligrams per hour. Now, because our concentration is in milligrams per ml, we don't need to convert that, and we can just incorporate 200 milligrams in 200 mLs. Now at this point, you just cross off your milligrams and you're left with mLs per hour. Now that you have the desired units, you multiply everything across and you end up getting 100 milliliters in 200 hours. Now when you multiply that down even further, you end up getting 0.5 milligrams per hour. Now that's the exact answer that you would have gotten had you been doing this through mental math. However, this long-handed dimensional analysis way ensures that you're not making any mistakes. Okay, our next example is epinephrine. We have 8 milligrams and 250 mLs. Our patient weight is 90 kilos and our dose is 12 mics a minute. Now, normally when you're using vasoactive medication, they tend to be weight-based, so mics per kg per minute. In certain institutions, especially in adults, they tend to use mics per minute. So for this instance, we're going to use mics per minute. So normally, while we'd start with the patient weight, since we're using a non-weight-based dose for our epinephrine, we're going to start strictly with our dose. So you have 12 mics per minute. And now, because we have mics in our dose, but milligrams in our concentration, we need to convert that. So 1,000 mics in 1 milligram. And now that we've got milligrams, we can convert 8 milligrams and 250 mLs. And again, we still have minutes here. We need to convert that out. So you have 60 minutes in 1 hour. You can start canceling out some milligrams, mics, minutes, and minutes, and we're left with just mLs per hour. So at this point, we can multiply everything on the top and everything on the bottom. And when you multiply that out, you end up getting 180,000 mLs divided by 8,000 hours. Now, if you divide that down even further, you end up getting 22.5 mLs per hour, which is what your pump should be running at. So if you're running epi at 12 mics a minute, you should be running on your pump at 22.5 mLs an hour. But what happens when you want to figure out what 12 mics a minute is in mics per kilo per minute for this 90 kilo patient? Well, it's actually quite simple. All you end up doing is taking your 12 mics per minute And remember, when we're trying to do mics per kilo per minute, we would need our kilos on the bottom here. So what we end up doing is taking our kilos, our 90 kilos, and putting them on the bottom, just like this. So that way you have mics per kg per minute. In this particular instance, we're saying 12 mics per minute for a 90 kilo patient. So when you do 12 divided by 90, what you end up getting is 0.133 repeating mics per kg per minute. And so you might not trust me on this. So in this next example, we're going to actually demonstrate. But your 12 mics per minute is the same as 0.133 repeating mics per kg per minute. Both should be running at this 22.5 mLs an hour. And we're going to show you this in our next example. So again, we said that our dose is 0.133 mics per kg per minute for a 90 kilo patient. Again, our epi concentration is 8 milligrams and 250. So we're going to walk this out just like we've been doing. So we have a 90 kilo patient with a dose of 0.133 repeating mics per kg per minute. Again, we've got mics and we got to convert them to milligrams. So we have 1,000 mics in 1 milligram. Now we can incorporate our concentration, 8 milligrams in a 250 ml bag. And again, we're still left with minutes, so we have to convert that even down. So 60 minutes in 1 hour. Now you can start canceling out all of your units. Make sure that you're left with just your desired units of mLs an hour, which we are. We're left with just mLs per hour. So now what we can do is multiply everything on the top and multiply everything on the bottom. And what we end up getting is 179,500 mLs per 8,000 hours. Now, if you convert that down even further, what you end up getting is 22.4 mLs per hour. Now, before what we got was 22.5 mLs per hour, and that was for 12 mics a minute. So why is there this discrepancy between 22.4 and 22.5 mLs an hour? Well, that discrepancy comes in because when we calculated it, we said our dose is 0.133 repeating mics per kg per minute. However, when we multiply that across, what we ended up doing was rounding that to 0.133 mics. And it's because we didn't incorporate that 3 repeating that there's that difference between 0.5 mLs and 0.4 mLs per hour. However, in the grand scheme of things, this is pretty stinking close and would be considered acceptable. So hopefully you have a better understanding of medication calculation using dimensional analysis. From all of us here at Revitalize Education, thanks for watching. If you liked the video, make sure that you hit the like button and subscribe to our next video.